Hello, everybody. We are right now starting a new session about CO2 and more precisely CO2 to sustainable aviation fuels. So the speaker, the chairman today is myself, Sébastien Dupraz from BRGM France. And well, first of all, thank you to be here and to attend this webinar. But we are going to have a short introduction on ECCSELERATE and ECCSEL, the program that is giving us the opportunity to have this session today. So first of all, some recommendation. We are expecting you to turn off your microphones and webcams in order to have a fruitful presentation. And the question will be, of course, welcomed at the end of the presentation, so you can use chat to write them down, and I will read them for our guest today. So ECCSEL is ERIC, so it's a research infrastructure that is dedicated to CCUS, and it brought a large consortium of 5 countries, which are Norway, France, Italy, United Kingdom, and Netherlands, and more than 28 research facilities with a range of wide diversity of platforms, about 100, that are working on capture, transport, storage, and utilization of CO2. The aim of this ERIC is, of course, to try to fight against the climate change and to have.
Sorry, Sébastien.
Please just turn off the microphone.
Hi, it's William here from OGS. You haven't started transmission. People is still waiting.
Excuse me?
People are still waiting. You haven't begun the transmission. I started now. Sorry, you have to start from the beginning.
Yes, okay, but you have not. There's nothing so much left right now, but we just are in a session about.
Yeah, people are not seeing you.
Oh.
I will start the transmission right now. Okay.
Okay.
You're all set. You are correctly set. So go back to the full screen slide, and I will begin the transmission. Sorry.
No, it's okay. Just I cannot see the button that was available about the. Oh yeah, it's here. Yeah.
The other display.
Yeah, I turned it off and I turned it on again. That's it.
Okay. Yeah.
Does it work?
No, not yet. I still see your editor window, your primary display. Under sharing, from the drop-down menu, you can choose what to share.
I cannot hear you very clearly. But,
Okay.
Because for me, it's written that everybody can see my screen, so it's curious.
Yeah, but you're not sharing the correct window. So under sharing, expand the sharing tab with a small triangle near the title. Show from the drop-down menu, select the second display.
I cannot hear you clearly. It's very hard.
But you are sharing your editor right now, not the presentation in full screen.
No, okay. So maybe if I turn off my camera, is that okay?
Yeah.
Like that.
Can you hear me now?
Sébastien, just put in presentation mode.
Yeah, but how do you do that? Because it's written that I'm already in presentation mode. So that's what it's doing.
No, yes, now your PowerPoint.
Okay, yeah.
Yeah, just it.
You can press the F5 key and it will go into screen.
Is that okay?
Yes. Now turn on your camera.
Again. Is that okay?
Yes.
And that's it. Okay, I will begin the transmission. At the end of the registered voice, you can begin.
So is it shared now? Barbara, is it shared?
Yeah.
Yeah, okay. So I can start again?
Yeah. It's fine.
Okay.
Thank you.
So once again, welcome to all of you. We are now starting, I hope it will work, a webinar on CO2 to sustainable aviation fuels. And sorry, yeah. We have some recommendation for you for this webinar. Just turn off your microphone and cameras, and you can write down in the chat any question you may have for our guest, and I will try to bring them to him at the end of his presentation. ECCSEL ERIC is a research infrastructure that is dedicated to CCUS, so carbon capture, transport, storage, and utilization. It consists of about 5 countries and more than 28 research facility owners, and it covers or it encompasses about 100 facilities around these 5 countries that are performing or providing research services. Of course, this is all in the goal of reducing global warming and promoting European vision of sustainable future. The ECCSELERATE project is one project that is coordinated by ECCSEL ERIC, and it started in 2020 and until this very year. And the goal of this project is to have a long-term sustainable operation for the ERIC and try to develop different assets, like, for instance, marketing, other services and accesses for the industry, to try to increase international collaboration and to extend the activities of the ECCSEL through other type of activities, namely the utilization of CO2 that I was mentioning. It consists of, like ECCSEL, different national nodes that are integrating and that are performing on research for industrial CCS projects. And in this program or project, we got specific attention with the capacity building program. And this capacity building program is divided in 3 sections. One of these is one that you are attending right now, which is a webinar series. So when we try to highlight different key topics that are in relation with the CCUS technologies, but also you have a specific workshop that could be performed, for instance, with summer schools. And you've got tailored training courses that are targeting industries, but also researchers and potential new user groups for ECCSEL. So today's agenda, myself, Sébastien Dupraz from the BRGM will share this session, and we have the pleasure to welcome Mohamed Pourkashanian, which is a senior expert in the CO2 field, and also is having a very long and, I can say, fruitful career on different subjects. He is head of the Energy Institute of the University of Sheffield, and also the managing director of the Transitional Energy Research Center and the Sustainable Aviation Fuel Innovation Center, which is quite a very topic today. So we have somebody that is very knowledgeable about that. And it's good to mention that he has been also acknowledged by the Order of the British Empire. So we are very pleased to welcome him. And well, Mohamed, if you want to start, the floor is yours.
Thank you very much. Now I have to do the presentation, which is okay. And now I am sharing my webinar. Is that right?
Not yet right now, but or at least for me, but I guess it will come soon.
Yeah, just move to the next slide.
Okay. Can you see it? Or?
No, you have to share again.
You're not sharing yet?
Can you see it? Yeah. Okay.
Yeah,
We can see it. Yes.
Right.
You can start now, Mohamed.
Yes, thank you, and great pleasure to be here. Thank you for the invitation, and good morning, good afternoon, or good evening to people who have joined the webinar. Depends where you are. What I will try to do in next 30-40 minutes is to talk really about how can we use carbon capture and utilization as a part of decarbonizing the aviation sector, which has become a very important topic. So let me start first with a very good news that, as you may have heard, last week we had the first 100% SAF transatlantic flight. This was the flight organized by Virgin Atlantic and Boeing, Rolls-Royce, and a number of other companies were involved to show that really we can use sustainable aviation fuel at both engines and fly a long distance or long haul flight. So technically it is possible, but this was to show policymakers and to show people who are involved in terms of SAF production that the only challenge is how to produce enough amount of SAF to be used for decarbonizing the aviation sector, and at the same time for the policymakers to make the right policies for the aviation sector to be able to use SAF. And it was more or less of a moonshot type project to show that technology is there, but we need enough amount of fuel and we have the right policy to do that. And this is where conversion of the CO₂ and hydrogen into aviation fuel becomes a very important topic for future. So let's start with looking at where does aviation sector sit within these 7 pillars that has been highlighted by IEA Net Zero 2050 strategy. And if you look at what has been predicted by the IEA, out of the 7 pillars, number 5 is hydrogen and zero carbon fuels, which is very much linked to the item 6, which is carbon capture, utilization and storage. But if you look at these 2 sectors, 5 and 6, you see that aviation, which is in here in pink sort of format, will need plenty of CO₂ and hydrogen to produce power to liquid to have a major contribution to the decarbonization sector. And an important part of future strategy for net zero. So why aviation is important? And in here I talk about e-fuels as well as, of course, the other type of fuel produced through biomass, for example. But we will see that in all of these topics, it is very important to look at the role of the carbon capture technology in order to decarbonize these fuels to a level that are acceptable for the in terms of the carbon footprint. So SAF is a critical part of aviation decarbonization strategy, and later on we will see that looking at all the possible way of decarbonizing aviation sector, SAF is the lead in order in terms of decarbonizing this sector. SAF is the only viable pathway for long-haul aviation. Again, I will show you the reason for that and why it is why the aviation industry believes this is for many years we need SAF. And number of mandates are happening within different countries. And for example, in UK, 10% mandate by 2030. US has similar sort of strategy, and EU in the same way, putting together different mandates for the use of SAF. And other countries like Canada, China, and India are starting to bring these sort of mandates. These type of mandates, of course, bring opportunities and challenges for the researchers and for different technology. So if you look at in terms of the strategies that are being produced by different countries, EU has their own strategy, a mandate for aviation, which is, I have put the number in there, EU 27, 2025, 2050 mandate. And then we have US, which is the first time that US is going to subsidize sustainable fuel production under the Inflation Reduction Act. And that is definitely 3 billion gallons per year by 2030. UK has 10% mandate of, which is equivalent to 1.5 billion litre, and by 2030, and the rest of the world, Australia, China, Japan, India, and many other countries are joining this sort of decarbonisation strategy. The mandate use of the sustainable aviation fuel creates significant challenges for fuel producers. And I pick up only the UK, and if we're talking about 10% mandate, which is only 10% of the fuel to be used in aviation, we're talking about 1.5 billion litres. So you see the quantity of the fuel that needed is quite significant. And this has to be made from sustainable sources by 2030. These will operate all under the greenhouse gas removal scheme to be certified in terms of how green these fuels are, how low carbon these fuels are. And they also have to apply within the RTF4 renewable transport fuel obligation. And then, of course, the eligible fuel, you will see that now waste drive biofuels is part of it. Recycled carbon fuel is another part. And more importantly, power to liquid is also highlighted. Power to liquid receives special attention, and therefore in this UK mandate, and I believe the same applies for other countries except US, where power to liquid is a very important part of the process, and we will see the reason for that. And for UK, special target has been set for the power to liquid. But in terms of technology or technology readiness, power to liquid is in the lower TRL, 3 to 6, rather than in comparison, shall we say, to HEFA, and therefore more research is needed. And also what you have to keep in mind that even that power to liquid may not be top priority in US, but we are dealing with sustainable aviation fuel as the international market. And when EU has a scheme that says the amount of CO2 that is used in this type of production of SAF has to be bio-based or the non-fossil fuel-based fuel, CO2. Therefore, if that is the sort of restriction, therefore, even producers in US looking at how to produce sustainable aviation fuel from non-fossil fuel-based CO2 and therefore to be able to market their fuel. And therefore, for example, technology like BECCS, where we produce plenty of CO2 from combustion of the biomass and capture the CO2, qualifies under that scheme, or a direct air capture. But why aviation is so important? If we look at the 2019, just before the COVID issue, and use that as the baseline for comparing what is happening on the aviation sector, and assume that the international and domestic flight was, shall we say, 100% at that point. In 2021, because of the COVID, you see the impact. International flight was still there, but much lower level, but internal flight was reduced significantly. And at that point, many governments predicted that it will be many years before aviation gets to the demand that we see in 2019. However, those predictions showed that was very optimistic, shall we say, and by 2023, based on the initial numbers that being generated and produced by the different organizations, shows that international flight will actually exceed what we saw before COVID. And by 2025, not only internal flight will reach that figure, but international flight will see a significant increase up to 20% more in comparison to 2019. And therefore, this is a sector that increasing in terms of the demand shows a significant increase. And again, if you look at the fuel consumption, jet fuel consumption of the commercial airlines, again, I have used 2019 as a baseline, showing that we were using by that time around 350 billion liters. And what happened then, fuel consumption reduced significantly because of the COVID. But if you look at the 2023, fuel consumption is back to the same number. And if you increase that to look at the figures by 2025, you see that figure increases significantly. And according to the, again, data that are available, for example, from BP database, world consumption of jet fuel will be about 454 billion liters, which shows a 17.2% increase, 17.2% increase at the world level, and for the countries of OECD at 26.4%. And if we implement at the moment, what is the production of the sustainable aviation fuel, you see the number 300 million liters. So it's a small fraction of what world needs. And if we look at the country's target of 10% mandate by 2030, we have to get that figure to 60 billion liters. So why sustainable aviation fuel is so important? Because if you look at this diagram produced by the, again, as a part of the environmental and energy of FAA office, you see that SAF or the use of sustainable aviation fuel has a major impact on decarbonizing aviation sector. Other technologies are there to reduce it, but SAF has the lead in order impact. And in here, there is a very interesting program available on Boeing website, which looks at the climate impact of the model. and it's a dynamic modeling tool. So you put your numbers in and you look at the technology that you're using, how that technology has an impact on the decarbonization of the aviation sector. In other words, reducing the net CO2 produced by the aviation sector. Now, this model looks at all the other area of decarbonization sector, all the way from new engines, fleet renewal, more efficient aircrafts, future aircrafts, as well as the operational efficiency and market-based measure, culture change, and renewable energy. And you see that in all these calculations, using a very optimistic and very pessimistic view, you see that sustainable aviation fuel plays a major role of over 50% on decarbonizing aviation sector. So it's clearly all of these data shows that really aviation fuel sustainable aviation fuel will play a major role in future. So what I have tried to do in here is really to show you that why sustainable aviation fuel is more important. And this is a very interesting diagram or table that has been produced by the aviation industry. You may hear a lot about hydrogen, how hydrogen will become important in the aviation sector, how batteries and fuel cell will become important, but this is what aviation sector believes that will happen by 2050. In all long-haul flight, there is no way that we will have any other technology except SAF. For medium-haul flight, there will be mainly SAF by 2035, but then other technologies will move in. And where you see electric or hydrogen or for fuel cell, you will see that they appear on small aircrafts for internal use and mainly internal flight and mainly for combination with SAF. So you see that really for long-haul flight, which contributes significantly, over 60%, 70% to the total CO2 generated from aviation sector, is the long-haul flight, and that's where we need SAF for many years to come. And you have to keep in mind that any aircraft produced today by Airbus, Boeing, and other manufacturers have a long life of 30, 40 years, and therefore they will be here for many years to come, and therefore SAF will be needed to fuel these aircrafts. Now, where power to liquid becomes very important is this data that has been shown in World Economic Forum report, and clearly shows why aviation industry is really focusing on power to liquid as the main replacement for the fossil fuel in future. So if we look at what we have at the moment, the baseline in this graph shows the fuel price, the aviation fuel price at this moment. And if we look at the technology that is available, you have HEFA, alcohol to jet, gasification, and power to liquid. Keep in mind that power to liquid, you have to have a carbon capture technology, whether it's a direct air or through combustion process, plus hydrogen, and then have a look at the percentage of the LCA life cycle analysis in terms of greenhouse gas reduction against the fossil fuel. In other words, how much fossil fuel you replace when you use SAF produced from one of these technologies. HEFA, which is available commercially, is a bankable product, only replaces the fossil fuel by at best 84%, but usually data is much lower than that, something around 78%. Now, if you look at alcohol to jet and gasification and Fischer-Tropsch process, even that you use carbon capture technology there, but overall carbon or jet fuel replacement, fossil fuel based jet fuel replacement, you are only talking about 85 to 94% at best. But again, the numbers are usually less than 90%. Now, if you move to power to liquid, where you need captured CO2 plus hydrogen, in other words, a way of utilizing the captured CO2, you see that using this fuel produced from power to liquid, 99% of capability of replacing jet fuel or fossil fuel-based jet fuels. So clearly shows that power to liquid has the biggest impact in terms of decarbonizing the aviation sector. But then you look at the graph, the bottom of that diagram, and you see that at this moment, the price of the power to liquid in comparison to other technologies are very high. And all of them, of course, higher than baseline, but power to liquid fuel is much higher. Now, however, you see a significant reduction, and by the year 2050, power to liquid fuel becomes even better in terms of cost than other type of process. And the main reason for that is significant improvement and the next generation technology on hydrogen production, mainly, for example, if it's a low carbon hydrogen, it is or blue hydrogen, you talk about capturing CO2 during the production of the hydrogen, or green hydrogen, and these are part of that US DOE hydrogen shot program that hopes by 2030 the price of hydrogen will reduce to $1 per 1 kilogram within 10-year period. And of course, at the same time, direct air capture becomes more important, much cheaper, but because of the availability of the unwanted renewable power, as well as, of course, the better technologies and more efficient technologies for carbon capture. So, and also I have to give you a cautionary note in here that in this graph, we assume that the cost of jet fuel will remain the same, but that is not really the case. We know that jet fuel's cost will increase significantly with time, and more importantly, as the demand for petrol and diesel fuel reduces because of decarbonization, refineries have no option but to increase the price of jet fuel that is produced at the same time. So I think there's a clear case that we do need SAF, and looking at a global challenge, I picked up the Europe. You see that every country within Europe, the sort of developed countries, and have target, whether it is Netherlands, Germany, France, all have target. Spain, Portugal, all the European EU countries have put together a target, setting up a target, and EU produces this SAF ramp up, of which shows how much it will be needed for what sort of percentage. And they have a very challenging but doable goal for future in terms of production. Now, what we also have to keep in mind that, of course, all of these significant requirement for sustainable aviation fuel also creates significant business opportunities. and job creation. So it is a project that has many advantages. And again, I have shown you in here a European program, European picture of what is happening where, and those has been highlighted in a report that published by Royal Society. We published this recently, back in February 2023. It's available on website if you look at it, if you wish to look at it. But what you can see that almost all the European countries have a strategy to bring the mandate or have plan how to replace the jet fuels by 2030. So I think that enough background knowledge in terms of why we need SAF. But what I will try to do next quickly is some of the results that we need to do, and especially for power to liquid, you see that how you have to look at all the carbon footprint, how does the carbon is produced, and how do we convert that to different type of hydrocarbons, and what is the hydrogen conversion efficiency, and what is the overall efficiency when we get to power to liquid. Some of this work has been published recently by our researchers and available through different journals. But if you have interest, just let me know and I send you these papers. But also, let me just, I'm looking at the time, I have to finish very quickly. So in terms of power to liquid, some of these techno-economic studies have to also include what sort of power we need for producing this, capturing CO2 or producing hydrogen that will qualify for 10% mandate. And I've used in this case UK and UK mandate, and you see that amount of CO2 that we need to produce under different scheme using different technology to qualify for the mandate. So yes, so let's look at the process of how you produce aviation fuel. The area that we are really interested and will play a major role is this role of the CO2 coming through the reverse water gas shift reactor, converting into the syngas, and you go through the Fischer-Tropper process, hydrocracking, isomerization, and you end up with bright hydrocarbon that available or is suitable as the aviation fuel. Keep in mind that as a part of energy security, availability of the waste and biomass and sugar and starch and oil, fat, and all that sort of feedstock is very limited. And therefore, if we want to produce what we said, 45 billion liters of aviation fuel, and at some point by 2050, over 200, 300 billion liters of aviation fuel, the only option becomes available is the power to liquid option, where you have CO2 produced from direct air capture or captured from combustion process, hydrogen produced from electrolyzer or blue hydrogen, and you end up with Fischer-Tropper or alcohol to fuel process and end up with a sustainable aviation fuel. And these are the sort of technologies available through ECCSEL. I think Sébastien talked about facilities that are available, and here are for some of the facilities that are available through ECCSEL, through the ECCSEL facilities line. So we said that SAF is a critical part of aviation decarbonization strategy, and we talked about 10% mandate, but now we focus mainly on power to liquid for jet fuel. This is a very fast changing technology within the value chain, and the innovator dilemma is how to reduce the cost. Production pathway for synthetic or PTL fuel is very broad and diverse landscape, and these are all depends really on availability. For example, the industrial scale production at this moment, we don't have that. We also where we have lower footprint for water and land consumption. If you are going to use SAF produced by biomass, you need plenty of water, you need plenty of land, and power to jet completely, power to liquid completely removes that sort of disadvantage. And as I showed you before, it has a main advantage of reducing environmental impact because it has the highest opportunity to replace fossil fuel. So, strength of the power to liquid for jet fuel is that, first of all, is net zero greenhouse gas emission, 99% fossil fuel replacement, lower water and land demand, and more or less you can also use it for drop-in capability. The challenges at the moment is high cost, green hydrogen mainly, and renewable CO₂, and power, mainly direct air capture. The main cost is really the power, but of course CO₂ available through biomass capture technology. And other challenges that we also look at is getting the ASTM certification for the power to liquid jet fuels. Opportunities is has the cleanest fuel in terms of impact on the contrails using power to liquid. And more importantly, through this process, you add value to the CO₂ captured. So in other words, CO₂ valorization becomes a reality where SAF will be produced from CO₂ and hydrogen. Threats is that, of course, using that technology, you can lock in with the liquid-based aircraft technology. But as I said, that's by 2050, we have that unless we see a step change activity. And CO₂ and green hydrogen availability, because everybody wants green hydrogen or blue hydrogen, but there isn't enough available. Just to highlight the UK research and innovation work that we're doing is looking at the feedstock. CO₂, initial feedstock is coming either from DAC or from power or from industry. We also have feedstock, another feedstock, which is hydrogen, which is coming from green hydrogen or blue hydrogen, in other words, hydrogen production with carbon capture. Once you have these feedstock, you have either direct route, FT reactor with multifunction catalyst, where you only need a single reactor, where you convert CO₂ and hydrogen to the syngas, or two reactors, reverse water gas shift reactor and FT reactor producing syngas, and syngas on FT produces hydrocarbons. And after hydrocarbons produce, you go through the post-treatment and you produce SAF, and then you go through the certification. Hydrogen certification technology, gasification technology, blue hydrogen, electrolyzer, and renewable power generation for electrolyzer is what we need as a feedstock. But you can see the importance of the carbon dioxide, whether it's produced from direct air capture or produced from industrial plant or produced from power plant. Because of the timing issue, this presentation will be available on website. I'm sorry that we are running a little bit behind. So the reverse photogastric reactor reactions is well known, how to convert CO2 and hydrogen into the syngas, and reverse photogastric reactor uses a different technology, different catalyst. And once you have produced that, you end up with aviation fuel or feedstock to Fischer-Tropsch. Or you can use much new novel catalysts where all the process of CO2 conversion to CO happens in the same reactor, and Fischer-Tropsch then takes over catalyst and produces hydrocarbons of a different long chain hydrocarbon, followed by a process of converting it to the right hydrocarbon and cyclic hydrocarbon needed for aviation fuel. And some of these catalysts are very simple, iron-based catalysts that do the job. Again, I go through these very quickly, different type of catalysts and different type of post-treatment needed. And then the certification becomes a very important part of the process, that how to certify to make these fuel safe for the flight. And the process of qualification is quite complex, all dictated by ASTM protocol, and how you go through tier 1 to tier 4 to certify these new fuels. Keep in mind that at this moment, no 100% SAF has been certified for flight. They are only being used for 20% or 50%, up to 50% blending. So, in a way, therefore, the process is that you produce SAF, power to liquid, from different from the technology we talked about, and you do characterization of the SAF in a lab, and then you do testing in terms of emission, and that's the whole process. And these are some of the facilities that are available in ECCSEL, and they are available for different users to come and test their fuels or catalysts or altogether the reactors. So just to finish, that really SAF and e-fuel roadmap, policy and evaluation analysis, market needs a clear guideline, and that is becoming available, national and international agreement, if possible, because aviation is international industry, and how to account for carbon footprint, building a regional SAF supply chain, and as we mentioned, CO2 is very important, so it has to be closer to where we capture CO2, and feedstock and conversion technology innovation, that how we capture CO2, produce blue or green hydrogen at the same time, and then produce aviation fuel, and then go through the pathway to ASTM approval. And at the same time, for the investors to produce a flexibility and optionality to de-risk their investment. And this is my concluding remark, that really PTL produced using sustainable renewable input is a promising pathway. We already seen that industry is focused on it. Main challenge is the total cost of synthetic or e-fuel, eSAF production, how to look at optimizing the heat integration and reduce the cost of CO2 if we are using direct air capture, and also goes through this process of ASTM approval. My apology that I had to go through some of these issues very quickly, but I now stop presentation and leave for some question time.
Thank you, Mohamed. This was a very nice presentation. Indeed, it was quite diverse. We got chemistry, we got pricing, and market, and all the issues. So it was very interesting to me, and I guess to all the people that were listening to you. Regarding question, we do not have some right now, but I have one on my own, if it's okay.
Yes.
I would like to know, because the way that you presented it, of course, power to liquid seems to be the best choice for many reasons, but there is this pricing issue, and at the same time we are aiming at renewable CO2. So my question was more or less it's targeting the direct air capture, but this is quite costly. And I guess that you have here that the European Commission is trying to acknowledge negative emissions. So
Yes.
I was wondering if it will, how it will affect the chain of production of SAFE. Do you think that it will have an impact or no?
Yes, well, of course, the cost that you mentioned is very important, because you want to produce SAF that reasonable in terms of cost. And direct air capture is a technology that we believe at some point in future will play a role in the amount of CO2 that's generated. However, what we can't ignore that some of the CO2 that industry now tries to capture, for example, cement industry, where they use waste and biomass, or power generation from from biomass biomass combustion, they are all considered as a CO2 that are available as a non-fossil fuel based CO2. And therefore, those becomes quite important feedstock for sustainable aviation fuel that generated from power to liquid. What I would say that power to liquid after 2030 becomes very important, because at this moment, hydrogen cost is very high. However, the technology is, we need to work on the technology to reduce the cost of refinery. In other words, the cost of production of the SAF, because we know the SAF is there, CO2 is there, available through different routes. But hydrogen is the cost issue, and once this hydrogen issue is resolved, I think power to liquid will play a major role. Sorry, I couldn't hear your question quite clearly. I hope I answered it right. But if I haven't picked up part of that question, please repeat.
No. It was answering it, so it's okay. Thank you for that question. And as there are no other reaction, I will just finish with one question, and this will be all for us. But it's do you think that there is some heterogeneity in Europe regarding this research? Is there some trends between countries regarding the way that they're approaching these different technologies, or is it quite a common point of view?
No, it is very interesting how Europe is looking at this. And for example, Germany is really a number of projects that is happening is all on the power to liquid. Very interesting projects that happening there. Norway is looking at it through the number of, again, on liquid or the gas to liquid, and then through that process to sustainable aviation fuel. UK is looking at alcohol to liquid or alcohol to SAF, as well as power to liquid. So there are some processes that are very common, and the good news is that European Union is also looking at some of the projects that hopefully will contribute towards this sort of research. And I believe there will be some announcement in January and in March regarding the non-CO2 impact of the SAF and the production of the e-fuels. So there are some ground for joint work, definitely. And I believe with the facilities that ECCSEL has, there are certain opportunities for future for industry and academics to work with SAF, with ECCSEL in terms of improving this technology.
Okay. Well, it's. I would like to first to thank you for that very nice, interesting presentation that give us quite a broad and dense overview of what is all about safe production and issues. I would like also to draw the attention to our audience that if they want to see that webinar again, it will be available on the ECCSEL website. So it's ECCSEL.org, and it will be also accessible through our YouTube channel. Meanwhile, I thank you again, Mohamed, and I wish to all of you a very nice day. And thank you for attending this webinar session.
Thank you very much.